Okay, we are going to start our class now. Yay! Evolution, its impact on human behavior. Huzzah! Well, Isabella, that's not typically how I roll, but in this case, I just have a hard time thinking that any of our administration would be mad at me for providing coffee for 11th and 12th graders who want it. Especially after, remember, you guys did research on this like a month or whatever ago, right? Remember that? I had you do the presentations about the impact of caffeine. Yeah, Riley, I don't know if anybody's watching these things, let's be honest. Okay, question for you to start class. Why do so many pregnant women tend to get morning sickness and throw up all the time, during pregnancy? Any thoughts on that? It is fairly common. Wondering if you have any thoughts on why. What might be the reason? Just go ahead and type it in. This is a Pear Deck question for you to type an answer to. I'm reading your responses as you're typing. I would prefer if you would not say I don't know and think about it for a second and come up with a theory. I don't care if it's crazy. Could be space Martians. I don't care. Just think about it. See if you can come up with a reason. All right, if you're saying because of the changes their body's going through, all right, fine. What does that mean? What would be making them puke? Boy, some of you are coming up with some creative answers. Some of you are getting very scientific on me. I'm not going to name any names. I won't do it, but I'm tempted. It's pretty vicious. I remember my wife, when she was pregnant with all three of our kids, she did have this. But boy, especially with our first, with our daughter, Abby, boy, when she was pregnant, like for the first 5 out of the 9 months, my wife, I think she pretty much just ate hot dogs. And, oh God, I forgot. It was hot dogs and like hot chocolate or something like that. She only ate like 2 things for months. Good, terrible. Let's see. Somebody said crazy baby dancing in the belly. So seasickness. Yeah, maybe. A lot of you are going with hormones, which is fair enough, although you're not being specific enough in telling me why, and that's okay. One of the boys, ladies, check this out. One of the boys says maybe it's because they're not having their period anymore. Okay, I'm trying to get the connection between that and vomiting, though. The brain isn't used to, okay, maybe the brain, something going on in the brain. Baby's immune system is bad, so the baby's getting sick, so wow, okay. The uterus may be taking up more space in the abdomen, thus putting pressure on the stomach and causing stomach acid to rise into the esophageal sphincter. Oh my. See, that actually sounds plausible. Ooh, blood sugar level changes. I like that. Interesting. Maybe the baby is rejecting the food. Ooh, okay. Very interesting. Thank you for your feedback. Let's, obviously this is a question we're going to answer by the end of today's class, or at least we're going to come up with a theory by the end of class, one informed by quote unquote evolutionary processes. So I don't want to assume that you guys have learned about evolutionary theory in your classes. or that you've learned about it in detail, or maybe this is the biggest one, you actually remember it. So what's going on in the chat bar here? Okay. Yeah, can you type yes in the chat bar if you feel like you could reasonably explain to me evolutionary theory right now? I won't make you do it, I promise. I just want to know if you feel like you could, like how it works. All right, a couple of you. Fair enough. Well, for the vast majority of us who feel less confident, let's dig in here. What is the theory of evolution basically about? I'm going to give it to you in two parts. This is the first part. The theory of evolution is arguing that every living organism lives in some environment, and that environment presents a challenge, in fact, a series of challenges to each organism. And I mean challenge like to its survival. That's a basic assumption of evolutionary theory. Every living organism is living in some environment which proposes or presents challenges to its survival and well-being. And this is the second part. It is those living organisms who adapt the best, who can change to meet those challenges, who are more likely to survive, not die. But more than that, not just to live, but to thrive, to have health and success, and then to breed, and thus pass on their highly successful, well-adapted genes to all of their offspring. This is the core of evolutionary theory. Any questions so far? We're going to get into more detail. I just want to make sure you're keeping up. Okay, so I'll explain the pictures in just a minute. Don't get all excited, X-Men fans. Any X-Men fans? Just me? Really, just me? No, I am sad. My dad likes, Riley, thank you for calling me old in veiled language. I appreciate it. You get enough. Wolverine, you see, is an X-Men. The X-Men supposedly have the powers they have because of genetic mutations. And that has something to do with what we're about to talk about. So that process of evolution that we just talked about, that adaptation, what are the actual mechanisms that drive that change in an in a species over time? What pushes it forward? It's really a combination of these two things. First of all, random genetic mutations. So an organism comes into being already having within itself some sort of alterations in its DNA structure, and these alterations are totally random. They just happened. So now I'm being ridiculous here, so I want you to listen carefully. Evolutionary theory says that typically these random genetic mutations are very, very, very tiny. You might not even notice them. And that over the course of millions and millions of years, these genetic mutations start to stack up. And only after a long period of time would you really notice a change in the creature. That's why the X-Men are kind of ridiculous examples. I mean, in the X-Men, the genetic mutation that these characters are born with are like massive and immediately noticeable. So Wolverine, for example, was born with incredibly heightened 5 senses, super strength, a healing factor, which, you know, if you cut him with a sword, he would be healed in about 30 seconds. Oh, and by the way, big bone claws that shoot out of his hands whenever he needs them. Now, according to evolutionary theory, it just doesn't work like that. It doesn't happen that suddenly and that immediately and that noticeably. Just trying to correct the X-Men. So it takes place over hundreds of millions of years, these genetic mutations, which are random. But here's the second part that's necessary. Here's a question. Does the genetic mutation actually help the organism to survive in its environment? Or does the genetic mutation actually get in the way? Does it harm the organism? According to evolutionary theory, the vast majority of genetic mutations are harmful, and so the organism will actually die. And when it dies, of course, its genetic mutation dies with it. But sometimes this random genetic mutation will actually help the organism to survive and thrive in its environment. And if it helps, then we see what evolution is called natural selection at work. It's almost as though the environment is somehow personified and the environment is choosing or selecting that trait as a favorable one in this environment. So you have a picture of a giraffe there. So the theory goes, why is the giraffe's neck so long? Because in its environment, much of the food sources are not on the ground, and therefore, you know, over time, hundreds of millions of years, the longer necks, so that they can survive and thrive. So these are the two mechanisms that drive the process of evolution. Questions thus far? Ugh, that coffee wasn't very good. Ugh. Seeing no questions, I press on. A little bit more, some of the basic terminology you should know. So if there has been a genetic mutation which is favorable in that environment, the organism will, of course, survive, not only survive, but they will do well, they will thrive, they will grow stronger. And because they grow stronger, they will have advantages that the other organisms don't have. They will then breed, they will mate with others in their species, and they will pass on this helpful new mutation, whatever it is. And slowly but surely, over millions of years, through regular good old-fashioned processes of sexual reproduction, that helpful gene will work its way all through a population. So the one that it has it at birth breeds. Let's say it's the animal kingdom and they have like 100 offspring. Now all those 100 have the helpful gene, and then those 100 all have 100 more. Now we've got however, what is it, 10,000 or whatever, 1,000, 10,000 now have it, and so on and so on. It's exponential growth. Until, before you know it, all of the creatures in that species have it. So over time, this is how species develop characteristics that make them more successful in their environments. And that process we call adaptation to the environment. Adaptation. So evolution is taking place in the creature, in the organism. But we can also say that adaptation is happening. It's causing them to be better suited for their environment. See, this is what Magneto in the X-Men believed. He believed that mutants are the next step in the evolution of humanity, and they shouldn't be, you know, deferring to regular old human beings. They should be breeding and making more mutants because they have such cool superpowers, and eventually they would take over rulership of the Earth. See, you never knew why Magneto was a bad guy. Now you know. All right, I keep on. So what's all this got to do with psychology, you ask? Thank you, Mr. Irwin, for helping me in my bio class. You're welcome. What has this got to do with psychology? As I said earlier, there's a field of psychology and it is called, cleverly, evolutionary psychology. And they're all about studying how every measurable human behavior gives evidence of being a result of evolutionary processes. So the idea is, guys, every human behavior that we could look at and study somehow needs to be explainable through evolution as a process. That is the basic assumption of evolutionary psychology as a field. So, question we need to think about and answer. Through genetic mutation and the natural selection, can the environment select for a behavior? Can evolutionary process select for a behavior? Well, the answer is no, and let me explain. If you think of most of your behaviors, aren't they really a complex series or a sequence of smaller actions? And don't even those smaller actions, don't each of those smaller actions require certain mechanisms to be present, like a certain body part, in order for those smaller actions to happen? So because our behaviors are so complex and because they require some prior body parts, mechanisms, things like that, we want to say no, natural selection doesn't select for behaviors. Rather, we want to say natural selection selects for small individual mechanisms or body parts that eventually, when you combine them, can produce something we would call a behavior. This will make more sense, I think, when I give you an example. I wonder if you've ever heard of the concept of altruism. You're in 11th and 12th grade. I hope you have. It's defined there for you. Altruism means sort of a desire to do good to other people for totally unselfish reasons. Like, I'm not hoping to gain anything from it. I just want to do something nice for you, just because. So psychologists, for example, have been asking for a long time, is that real? Does that exist? And whether we agree or disagree, the point is this: to act in an altruistic manner, that's a behavior, right? So if I sent you guys all $100 in the mail, just because I felt like being nice, that's it. That would be altruism. That's a behavior, right? If you think about it, though, there's a whole bunch of smaller things that have to develop in order for me to get to the point where I do all that. Like, I have to have $100. I have to have a job. In order for me to have a job, I need to have, functioning brain. In order for me to have a functioning brain, neurotransmission has to happen. In order for neurotransmission to happen, I have to have cells. This is what I mean, that natural selection selects for very, very small individual body parts, behaviors, small developments that over time start to pile up into what we can then call a behavior. Or how about swimming? This is a behavior, right? Does natural selection select for the ability to swim? No, but it does select for a whole bunch of other things that over time stack up and start to allow us to swim. What are some smaller things that need to be true before you could ever be able to do this thing we call swimming? Think body parts, smaller behaviors that are components of swimming. Let's think about it for a second. I'll let you think. We're typing it in the Pear Deck, not the chat bar. All right, what do we got here? Some things you all said are smaller components of swimming. Having limbs. Okay. Yeah, guys, without arms and legs, it'd be pretty tough for us to get anywhere in the water, right? Lung capacity / holding your breath. Yeah, you certainly have to be able to do that. Let's see. Buoyancy. Yes, if you had no body fat, you just sink like a stone. Well, you'd be more likely to sink like a stone. Just looking to see what else we got here. Once you're underwater, what's to stop all that water from rushing into your body and drowning you immediately? There have to be various different seals, you know, inside your ears, your nose, etc., stuff like that, right? Yep. You not only have to have limbs, you have to be able to think about all the behaviors you have to do before you're swimming. Like, for example, before you can be quote unquote swimming, don't you have to learn how to kick? What else? I mean, you got to kick. What else can you think of? Other behaviors you might have to do before you can really say that you're swimming, you know, like an Olympic swimmer who actually knows what they're doing. Let's see, you got to learn how to kick, learn how to hold your breath, keep your eyes open underwater. That's a behavior. Sure, if you didn't keep your eyes open, you'd run into rocks and kill yourself, right? Yeah, what about moving your arms? What about doing this? This is a behavior, right? Learning how to float. What about that rhythmic breathing thing, right? When you take a stroke, you have to turn your head up. And yeah, there's all kinds of component parts to this thing we call swimming. It's actually really complex if you think about it. There's so many more that we probably could think of if we had time. And all of those smaller things had to evolve, had to take place and be present before we could say that we are doing this behavior called swimming. Does this make sense? The idea that natural selection selects for much smaller things, not for an entire complex behavior. All right, well, seeing no objections. Riley says, imagine if we had to think about all that while we were swimming. Indeed, right? Guys, imagine. I wonder if you know anyone that's ever experienced paralysis and had to relearn how to walk. I mean, something as simple as that. Or somebody who's had problems eating and they have to relearn how to swallow. I mean, there's so many behaviors that actually involve more moving parts than you think. We take them for granted because we've learned how to do them and because we have all of the necessary equipment to be able to do it. All right. So the particular topic we're going to be thinking about in regards to evolutionary psychology is we're going to think about the feeling and the observable, measurable behaviors associated with what you and I call disgust. This young lady here is making a face which psychologists have studied, which is a typical face when one is experiencing what we call disgust. It usually involves crinkling up the nose. Sometimes the mouth even opens a little bit. Kind of looks like that. What I want to do now is show you a video.
What is disgustology? Well, disgust is an ancient emotion. It drives our hygiene behaviors. It puts us off coming into contact with things that might make us sick. So when we sense that there's something dirty and contaminated on our hands, it makes us more likely to wash them. And if someone sees us not washing our hands, then we feel ashamed. These are very powerful emotions, but we can harness them to encourage effective hygiene habits. Hand washing with soap helps prevent the spread of potentially fatal infections, such as diarrhea, pneumonia, pandemic flu, and many more. The story of Lakshmi's short life shows the importance of hand washing. Born in rural India, Lakshmi falls ill with diarrhea and a bad cough at 5 months. She recovers, but repeated diarrhea and respiratory illnesses leave her malnourished and vulnerable to infections. Age 3, she's so weak after suffering from measles that an infection that is never even diagnosed causes her death. Sadly, there are many stories like Lakshmi's. Every year in developing countries, more than 7 million children die before their 5th birthday. But the illnesses that she and millions of others experience are preventable. Washing your hands with soap can take as little as 10 seconds, and it really does save lives. Here at the Hygiene Centre, we want to help improve millions of lives by teaching the power of this one small action. By pledging to wash your hands with soap, you can help us in our mission.
See, so this is Dr. Val Curtis. She is a researcher who works as you can see, in the field of the emotion and the behaviors of disgust, and also how they impact hygiene. And obviously, as you just saw in that video, it's important. And certainly, God knows, as we've learned in 2020 and early 2021 with COVID, personal hygiene can be really, really important. It can, in fact, sometimes be a matter of life and death. What Dr. Curtis has spent a long time researching, though, is how this behavior, practicing personal hygiene, gives evidence of being a behavior that has evolved over time and helps us as individual organisms and as a species to survive and to thrive in our environments. So here is a piece of research from 2004, and Dr. Curtis and her team of probably ill-paid, overworked graduate research students. Not that I'm bitter. It's a good example of a piece of research that's aimed to try to give evidence to the evolutionary basis for a particular behavior. Dr. Curtis and her team wanted to find out if there are patterns in people's disgust responses. Do we show disgust and the behaviors associated with it in any kind of predictable ways? So the procedure you can see that was used, it was an online survey. We haven't seen too many of those as research studies this year, have we? Online research study. Now, even just by looking at that method of research, your brain should be going a little bit here about strengths and limitations. Anyway, she and her team created an online survey. 77,000 people participated from 165 countries. And each of them was shown, part of the survey, they were shown 20 images, 20 pictures. And for each picture, they were asked to rank their level of disgust from very high to non-existent. Now, of those 20 images, 7 of them were presented in pairs. So you would see 2 images at the same time. Now, with those paired images, one of them was something infectious, like something legitimately infectious. So maybe it was a picture of, like, seriously, like somebody's vomit. And the other paired image was something visually similar, but not infectious. So maybe next to the picture of somebody's vomit was an image of some sort of mildly yellowish green slime. And what they found through this survey of 77,000 people from across the world is that people seem to have been most strongly disgusted by images of things that actually threaten our immune system. Like, that means they ranked higher the images of things that were legitimately real world infectious. They ranked them higher, more disgusting. They also noticed in their findings, this was interesting, that the older you were, older age seems to correlate with lower ratings of disgust. And then, third finding, overall, women have noticeably higher disgust ratings than men. I wonder if any of this is starting to click with you, given how I introduced the class today. See, Dr. Curtis and her team said, it seems as though we might be able to see at work here a connection between our behaviors and feelings of disgust and the process of human reproduction. Like, what? They are suggesting that there is an evolutionary tie between human feelings of disgust and human reproduction. Think of it like this, guys. If a woman is pregnant, I don't know if you knew this or not, but when a woman is pregnant, did you know that oftentimes her immune system is lower, that it is weaker? Did you know that? What about this second finding? The older you are, the less disgust you feel. When do women tend to have babies? What ages? I mean, they can usually start with the onset of puberty, 13-ish. And typically women lose that ability by menopause. Here's the point. It's probably fair to say that having children is something that's much more common in younger women than older women. And gender-wise, who registered higher feelings of disgust? Women did. So if you put all of that together, the idea is, maybe evolutionary forces have worked together to make it so that women who are younger, who are of childbearing age, and who have compromised immune systems when they're pregnant are more likely to feel disgust. And here's the point. And because they're more likely to feel disgust, they're probably going to eat fewer things that might potentially be actually bad for them. Here's another piece of research 1 year later, which is very similar. Very similar. Fessler and his team of overworked, underpaid graduate assistants wanted to investigate if disgust sensitivity in the first trimester of pregnancy was heightened. What's the first trimester? Anybody know how that works? Yeah, tri equals 3. So typically a woman is pregnant for roughly 9 months. The first trimester would be conception through 3 months, so the first third of pregnancy. And that is most typically when pregnant women will report morning sickness. So they wanted to see if disgust sensitivity in the first trimester of pregnancy was heightened. Once again, procedure. A web survey, an internet-based survey, was given to 691 pregnant women. So that's quite a sample size. Average age, 28 years old. So that's right smack in the middle of prime childbearing years. And they answered, of course, a whole bunch of questions, but the things we want to notice is they answered some questions about their current level of nausea. So remember, these women are pregnant. They were at, what is your current level of nausea, using a 16-point scale. So they had a lot of options. They were also asked about their disgust sensitivity in 8 different areas. So for example, one of the areas was they were asked about their feelings of disgust regarding a variety of foods. They were asked about their feelings of disgust related to a variety of animal contact. Maybe petting an animal, getting licked by an animal, stuff like that. Disgust sensitivity regarding bodily products. Shall I name some? No, I won't do that. Contact with toilets, those types of areas. What did they find in their web survey? They found that, first, disgust sensitivity related to food and to bodily products, blood, sweat, feces, urine, etc. Disgust sensitivity related to food and bodily products was higher in first trimester women compared to second trimester women or third trimester women. So it is higher at the beginning of pregnancy, the first 3 months. And they found that disgust, even amongst that group, was especially high in relation to food. So what does all that mean? What were their conclusions? First of all, they said, well, we went into this thinking with the hypothesis that disgust towards food would be highest during the first trimester, and that seemed to be supported. And from there, as good evolutionary psychologists, they concluded, this may be evidence that nausea and vomiting in women who are in the early stages of pregnancy, nausea and vomiting are evolved behaviors which evolved to protect the fetus in case the mother should eat something truly dangerous, something poisonous. Maybe that's why pregnant women are throwing up so often. It's an evolved behavior to protect the fetus. So guys, if you're not getting the chain of logic here, let me walk you through it. According to evolutionary psychology, what's the connection between evolution and our feelings and behaviors we call disgust? What's the connection? Fact. This is where we start. Pregnant women have a lowered immune system. The reason they have a lowered immune system is so that the body doesn't attack the fetus. So this we know. Second fact, many of the diseases most dangerous to human beings, not all of them obviously, as we learned last year, but many of the diseases that are most dangerous to humans are food-borne. In other words, around the world, a lot of people die from diseases that are carried through food, spoiled food, uncooked or undercooked food. This is a fact as well. Now here's where we take the facts and evolutionary psychologists will begin to make correlations. They will begin to connect it to theory. Here's the theory. But early human beings, so we're going like way back, early human beings. You know, hunter-gatherer types, you know, before maybe what you and I would call settled, quote unquote, civilization. Those early humans couldn't afford to be picky about what they ate, right? Hunter-gatherers had to kill something and eat it, and they couldn't be real choosy. And if they, you know, managed to bring down a mastodon or something like that, they would have to eat off of that for a while. And even if it started to spoil, and even if there were flies around it, they couldn't be super picky. So here's the conclusion. Maybe natural selection selected food fussiness. You know, oh, that doesn't look good. Oh, that smells bad. I'm not going to eat that. Maybe natural selection selected food fussiness to combat the reduced immune defense that is present in pregnant women. Is this making sense to you? See how they get to connect it to evolutionary theory? So you understand now one example, I hope anyway, of how evolutionary psychology looks at human behaviors. What I want to do with you here at the end is let's step back. And instead today of focusing on evaluating the studies themselves, which, by the way, you should do and should be able to do to some degree, let's step back and ask an even bigger series of questions. Like, what about the field of evolutionary psychology itself? I want to share some thoughts with you because I know this is a new topic for you, and I'm not just going to say, well, what do you think? I'm not sure you're informed enough to be able to do that just yet. Don't mean to be insulting, just trying to be honest. Some things to consider. Excuse me. I think the first thing to consider, guys, is this. If you've been following what I've been talking about today, you have to notice that this field involves a great deal of speculation. If you don't like the fancy word, a great deal of informed guesswork about our environment. So think about those quote unquote early humans. That's why I've got the picture of the Lego there in case you weren't getting it. Think about these quote unquote early humans, the hunter-gatherers, the sort of pre-civilization people. We know, having looked at the basics of evolutionary theory and what it's about, we know that evolutionary theory assumes that all of us as living organisms are trying to adapt to some environment. We're trying to adapt to something, and it's to the environment we live in. That's a basic part of evolutionary theory. Well, we don't necessarily know very much about the environments in which these early humans first evolved. In terms of actual hard evidence, we have very little hard evidence about these people's environments. We have archaeology. We have very, very early historical records, but frankly, even those historical records, especially like written records, that all came after the people we're talking about. So I think we have to confess that we don't really know a great deal of hard factual evidence about those early humans' environments. Therefore, we have to admit that to some degree, evolutionary psychology is based on educated guessing, educated theorizing, rather than on observable facts. So as I was walking you through the Curtis and the Fessler studies, you can kind of see that. They take the result, they take the findings of their research and they say, so probably this is why we got the facts that we got. The key word there being probably. So one thing we have to say about evolutionary psychology is that it relies on us being able to make assumptions about the environments of our predecessors, perhaps millions of years ago. And we really don't know that much about them and their environments. It makes no difference what I say. You've already decided I'm guilty. The witch can read minds. Aha. Here's something else we need to admit. Evolution-based theories are generally hard to verify empirically. That's a fancy way of saying evolutionary-based theories are generally hard to prove through evidence. What does that mean? Well, evolution, as the theory lays it out, cannot be replicated in a laboratory setting. I mean, guys, I hope you can agree that's true. If you're a good scientist, you're looking for empirical, verifiable data. And not only that, but you're looking for empirical, verifiable data that you can replicate again and again and again through experimental processes. Well, evolution is supposedly something that takes place over hundreds of millions of years, right? So we can't really do that. We can't replicate it in a lab. So critics of evolutionary theory would charge it with what's called ad hoc reasoning. It's a Latin phrase. Should have given you a Latin definition, but ad hoc rationalization. What the heck does that mean in Latin? It means to this. Something that is not generalizable, not intended to be adapted for other purposes. Mr. Irwin, I don't know what you're talking about. Basically, when you hear that phrase ad hoc reasoning, it means this. We're taking something that we can observe actually, empirically, with our eyes, ears, smell, taste, touch. And then from there, we are creating a story or an explanation for how it developed that is unverifiable. Now, just in case there's any of you that are hearing me to be saying, Mr. Irwin says evolutionary theory is bad, I'm not saying that at all. What I am saying is that remember both of those words, evolutionary theory. A theory is an explanation for something that is based on, we hope anyway, the best available evidence. Some theories are better than others. Some theories are based on more evidence than others. I'm simply trying to say here, guys, if we cannot replicate the processes of evolution in a lab, we do need to reserve the word theory. That's all I'm saying. And in this class, where we're trying to be able to draw actual cause and effect relationships between things, this is a bit of an issue. And the fact that evolutionary psychology relies on ad hoc reasoning is even more significant when we consider that evolutionary psychology as a field assumes that evolutionary theory as a whole is valid. It assumes evolutionary theory is valid. And so this could mean that in the field of evolutionary psychology, it has to be guarded against. We have to be very careful not to fall victim to confirmation bias. I hope you can remember from earlier this year what confirmation bias is. It means that we're looking for evidence of something we already believe and ignoring evidence that doesn't agree with what we already believe. So in other words, guys, you could go back to the Curtis study we just looked at a few minutes ago and the Fessler study we just looked at a few minutes ago and say, well, you guys are drawing the conclusion that the behaviors you got through survey data correlate to, connect to evolutionary processes, but is it possible that that's because you came into the research assuming that evolutionary theory is true? And that's why you see these things as products of evolutionary theory? That is at the very least a logical possibility that has to be taken into account. Oh my God, he's bungee jumping. Have any of you ever gone bungee jumping? Say yes if you've ever gone bungee jumping. Sally, I said say yes if you have. Let's come on now. None of you ever gone bungee jumping. Good. Thank you for not being insane. You want to? Oh. Why? It looks fun. Flying through the air and letting gravity potentially kill you? Okay, fine. All right, fine. Why? I mean, is it because it would give you a sense of excitement and adventure? It would get your heart rate up and all that stuff? Go on a roller coaster. Go home and watch The Ring. There are other ways to get your heart rate up and feel a sense of excitement. Drive a little bit over the speed limit. No, don't do that. Some more sort of big picture thoughts about the field of evolutionary psychology. One other thing we need to talk about is this. Evolutionary arguments tend to underestimate the key role of cultural influences. Culture, guys, is important. When we're done with the biological level, our next unit, the big unit before we end the year is the cultural level, the socio-cultural level of analysis. And you're going to see, I think, more and more that cultural differences are really important in human behavior. And evolutionary arguments tend to assume that quote unquote humans, like across the world, are basically the same. Thanks a lot, Kylie. You get a ticket? I don't want to hear about it. I said I was just kidding. I'm on record. Are humans basically the same? I mean, we could argue that, yes or no, but what about cultural differences? Are cultural differences meaningful? Evolutionary psychology tends to downplay cultural differences. So, yeah, of course, some behaviors are universal. They appear in every culture across the world, such as disgust, for example. Remember, the Curtis study studied people in 165 different cultures around the world. So absolutely, some cultures are universal. And if we're going to study those, then, maybe taking the evolutionary perspective would be more useful. But there are some behaviors which seem to be very culture specific, that are not universal, that do not appear in every culture, like bungee jumping or breakdancing. Or name for me some other behavior that Americans in 2021 participate in that maybe some other cultures in the world don't. That was me asking you a question. Maybe you missed that. Can you think of some behaviors that Americans in 2021 participate in that maybe people in other cultures in the world don't? Wow, I thought you guys would be able to help me with this. Well, that just means that you're, kind of wrapped up in American culture, and maybe you're not as familiar with other cultures as you thought you were. I gave you an example of bungee jumping. I'm not saying only Americans bungee jump, guys, but there are a lot of cultures around the world that don't. Going to musical concerts, gathering in very large numbers and paying an obscene amount of money to go see a famous singer. Yeah, not every culture in the world does that. Putting ice in drinks. Ooh, Courtney, I like that. What cultures don't put ice in drinks? Do you know of any? Mm-hmm. Let me see. Yeah, like any significant difference. I think, something people do, some behavior or some attitude. Lisa and Kylie, not eating lots of fast food. Yes, guys, there are some cultures that don't even have fast food because they don't live, because they live in very rural areas. Eating cheese. I suppose there are some cultures that don't eat cheese, although I'm not familiar with them off the top of my head. Anyway, you get the point. Can evolutionary psychology really be stretched to explain every human behavior, or is it maybe better to say, yeah, maybe evolutionary psychology explains some behaviors that are universal, like, eating just at all versus, eating fast food versus not. Maybe evolutionary psychologists stick to the ones that are universal. So the role of culture, evolutionary psychology tends to downplay that, and maybe they're over-claiming their explanatory power for all human behaviors. Maybe some of those behaviors really are culture specific. Here's a couple more. We're almost done. We do want to say some positive things about evolutionary psychology as we close here. One thing that makes evolutionary psychology really important and helpful is that it does provide us with a framework, a unified, consistent framework within which we can try to explain all human behaviors. That's what psychology is about, right? Psychology is a field which is trying to scientifically study and determine why human beings are the way they are. Well, psychology is often criticized for giving too many answers to that. Well, evolutionary psychology does provide a unified structure within which we can try to explain all human behaviors. So it's got that going for it. So, like I said, this year we're studying human behavior through three main lenses: biological, cognitive, and socio-cultural lenses. And there are others that we're not going to be studying very much. So, for example, we're not studying developmental psychology, like the stages of life that we all go through as human beings. That's important, though we're not studying that. Health psychology, relationship psychology. There's so many different subfields and therefore sub-lenses through which we could study human behavior. In evolutionary psychology, some say, maybe evolutionary psychology is the overarching theory that maybe finally can help us to understand all human behavior. So are there definite limitations to evolutionary psychology? Absolutely. But it also holds great promise. And that, ladies and gentlemen, is the end of my presentation for today. Yeah, Sally, people that don't like blue cheese, I really don't know what to do with them. It's delicious. I was expecting to get some comments immediately saying blue cheese is not delicious, it's disgusting, you're disgusting, you know, that kind of thing. Yeah, it stinks, but it tastes good. There you go. Kylie, what? Lactose intolerant, map of the world with the highest lactose intolerance. It's really interesting. Just give me a quick one-liner. Why is it interesting? What would we find if we looked at that? Interesting. Well, ladies and gents, going to switch over here to our good old class website. Are you all looking at the class website currently? I hope so. Somebody let me know. Sometimes things don't work. No, I meant, are you looking at the class website like on your screen? I'm trying to project it. Yeah, that's what I thought. Google Meet is doing some weird stuff. It used to let me switch between tabs, like there was a button that says switch to this tab. Now, like over the last week, it's not working, and I hate it. Okay, so you're looking at our current unit, biological level. Just wanted to remind you of what's coming up. So again, here we are today. I already have introduced to you your exam for next Thursday, but there it is again. Remember, you're gonna, those are the 3 topics that you need to be ready to answer a prompt about. That's bad grammar, but you know what I mean. Genetics, pheromones, and our topic for the day, evolution. When you show up next Thursday, I will have pre-selected one of those topics for you, and you will have to answer a prompt on that topic. So you need to be ready for any of the 3. When class is over, I'm going to post a Quizlet study guide so that you guys will have that to help you be ready for next Thursday. Monday, no escuela at all. Not even asynchronous. Martin Luther King Jr. Day. Next Tuesday, the 19th, we will meet because it's a blue day, and it is a catch-up day. No new assignments, no new information. Yes, you need to show up. I am taking attendance, but it's a day for you to catch up either on my class or somebody else's. Wednesday, the 20th next week, once again, no escuela. It is inauguration day. You have no school. And then, next Thursday. So this is going to be the next time I see you is next Thursday, January 21, when you will have your examinación. So, any questions for me about upcoming calendar? Anything at all? Going once, going 2 times. Sold. Okay. Well, any political comments regarding yesterday's impeachment of President Trump? Just thought I'd ask before I let you go. I mean, I don't know. I feel like letting you go like 5.5 minutes early is a bit too much. Yep. Yesterday was history. It's pretty important when something happens for the first time in 233 years. So yeah, either our political system is way out of whack, and or President Trump is a pretty significant exception in the history of American presidents, or maybe both. We've had 4 total presidents impeached. The first was in 1867. The next was 130 years later, Bill Clinton. Now all of a sudden we got same guy twice. Either he's really bad or Our political system is changing. Yeah. Yeah, Kylie technology is definitely amplified, especially this president, and that was his choice. He was the one that started using Twitter, man. Anyway, so, yeah, I don't know. I don't want to go on with that. It's 1:15. I'm done. We're finished. And unless you have any questions, you are dismissed. Enjoy your weekend, ladies and gentlemen. Get some rest. Bye. You're quite welcome.